This is the four-sister race, okay? It's a four-sister race. Four sisters are running a race. It's a 1,000-meter race because this is the distance. And it looks like most of the sisters finished within about 10 minutes because this is the time in minutes. Now, Alberta is the solid line, okay? Alberta is the solid line. So one mistake that I saw people when they wrote their announcements, remember the task was we were supposed to pretend to be announcers, and we were supposed to write what took place in the race. We were supposed to announce the race. And I noticed that some people, and it's probably just a mistake, but they got the sisters' names wrong. In other words, they described the behavior of one sister but gave the wrong name, or they flip-flopped halfway through the story. So Alberta is the solid line. So when we look at the behavior of the solid line, that's Alberta. So what I'm going to do is I'm going to go through one person at a time, describing the behavior of each person, and then we'll put it all together in real time to kind of understand what took place in the race. So remember that the x-axis represents the time, the y-axis represents the distance that they actually traveled. So Alberta does not move any distance for almost 1/3 of the race. Now, if I were to guesstimate, I would say for the first 3 minutes, Alberta stood absolutely still. In other words, at 1 minute, Alberta did not move any distance. If we think about an XY plane, the time is the x-coordinate and the y-coordinate is the distance. So if we look at Alberta's graph, when x equals 1 minute or 2 minutes, she does not have a corresponding y value yet, according to this graph. So Alberta literally stood at the starting point of the race, which is 0 meters, right? This is 0 meters, for about the first 3 minutes of the race. Then the one thing that I thought was very important was that everybody noticed that Alberta had a steady pace. In other words, she had a constant rate of change, which is good because we're talking about linear equations. And of all the graphs, the only linear function or behavior is Alberta's. So she ran a steady race, a steady speed. Everybody got that aspect right. And then if you look at the time, this is first place, this is second place, this is third, and this is fourth. So if we think about Alberta, she actually got first place. She was the first one to reach 1,000 meters with regards to time, because the time is being measured from left to right. So she was the first one to reach 1,000 meters. And we'll just pause right there. So that's Alberta. Betsy, on the other hand, was the dotted line. So if we follow the dotted line, it looks like for the first minute, the same thing with Betsy. She doesn't really move. But as time goes on, Betsy slowly increases her distance. And it gets to the point, if you look from about here to here, in other words, 8 to 9 minutes, Betsy is moving pretty fast. She makes almost 500 meters in the time of about a minute or so, which is really almost kind of impossible. I don't know if you, well, not really, but in a time frame of about 2 minutes, she travels almost 500 meters. So what does that mean for Betsy? Well, Betsy, when the race started, she kind of stood still, didn't really take off, started going very slowly, and as time increased, she picked up the pace. So one thing I want to clear up, and this was a common misconception, not very common, a couple people got this wrong. The curve does not represent the path in which Betsy ran. The race was a straight line, 1,000 meter dash. Betsy's curve is based on the behavior. In other words, Betsy started off very slow and then she increased. The slope of the line determines the actual speed at which the racers raced. We know that Alberta was at a constant rate because her slope is constant. But if I think of this pencil touching the curve, as Betsy traveled through the race, her increase in slope or her increase in speed becomes evident. In other words, if I think of the slope of this little segment, think of my pencil as representing the slope of the curve at that particular point in time. As she traveled the race, her slope increased. Slope is the rate of change. Her rate of change is her speed. So over time, her speed increased. Okay? But that is not the path she traveled. All these sisters ran a straight line. She finished third. Now, if we look at Dora, Dora is the dashed line. Dora immediately starts with a steady pace, but probably around the 2.5 minute mark, or 2 minutes or 3 minutes. It doesn't, we're just studying the behavior. What what Dora did is she stopped. She did not move. So from this period in time and this period in time, her distance did not increase at all. A lot of you guys recognize that Dora did something at this point in time and got the time right, but some of you said she slowed down. No, if she would have slowed down, there still would have been an increase in distance. She literally stopped. Some of you guys jokingly said that she stopped to get a cheeseburger. Somebody said she was stung by a bee. Somebody said she found a monkey. Somebody said that Dora looked in her backpack for a map. Somebody said that a swiper swiped her shoes. But if you said that she stopped, you were correct. Okay? So here she stops for a point in time, and then she takes off again at another steady rate. However, if you look, the angle or steepness of the slope is not as great as it was in the beginning. And some of you correctly guessed that she took off at a constant rate, but it was a little bit slower. In fact, one person said that after she ate McDonald's, she was feeling sluggish. Or one person said she ate Taco Bell. She was feeling sluggish and couldn't finish the race at the same speed that she started. She actually came in fourth, which was after the 10-minute mark. So now lastly is Karla, which is like a dash with a point in between each dash. Her behavior is this line here. So if I were to label these, this is Alberta. Okay. This was Betsy. And some students did this and it was very helpful. And then this was Dora. And then this was Karla. Now if we look at the behavior of Karla starts doing something immediately with regards to time. In other words, as soon as the race starts and they start tracking the time, Karla is moving, but her starting point is not at 0 meters. Her starting point looks at, 450, 500 meters. So she starts literally in the middle of the race. Not the middle of the race time-wise, but the middle of the distance. She starts at about the 500-meter mark. She lost because she went at a much slower rate. Then the question asked by a student was, why did she lose? Why didn't she come in first? Because her slope was much slower. In other words, the slope represents her speed, was slower than the speed of Alberta's. So at this point here, Alberta caught up to Karla and passed her. Karla still got second place. Now creatively, you guys noticed that and you said that some people said that Karla was disqualified. Some people said that Karla was injured, so the sisters agreed to let her start the race halfway through. And that's okay. But the key point about Karla's behavior is that she started at about the 500-meter mark. She ran a steady course or a steady speed and finished in second. Now, if you understand all that behavior and you had to write the announcement, in other words, you're the announcer giving a play-by-play of what's taking place in this race, I put something together a little bit like this, and there's probably some grammar here, so I hope my English teacher friends that read this don't give me a hard time. They probably will, though. They can't do calculus, so. That's a joke. It's not a very nice joke. In fact, they'll probably give me a hard time. So anyways, let me get this in the shot. All right. So this is what Mr. Adams typed up, okay? Knowing that behavior, I said that the four sisters, Alberta, Betsy, Karla, Dora, began at the 1,000-meter race with some odd behavior occurring. For example, it appears as if Karla began to race at the 500-meter mark. She was clearly cheating. That's my take on it. Meanwhile, Dora seemed to be off to a good start, yet for some reason, Alberta was just standing still. Also, Betsy was barely moving. So at the beginning of the race, I'm describing the beginning of the race. Alberta isn't moving. Betsy's moving very, very slow. Okay. Karla started at the 500-meter mark. So the beginning of the race is what I'm talking about in that first paragraph. Now, I noticed that there's some changes in behavior about the 2-minute mark. So I say we're about 2 minutes in, and now Alberta takes off with amazing speed. Yet for some reason, Dora has stopped at McDonald's for a Big Mac. So I'm noting that one person, Dora, is stopped completely. She's not moving forward. That Alberta is starting. And then I'm also noticing she's starting at a very quick rate. And Alberta eventually passes Dora shortly thereafter. So she is quickly catching up to Karla, who is currently in the lead at about the 2-3 minute mark, who was cheating, by the way. While Karla was in the lead, Alberta is in second. Betsy is increasing in speed, and Dora is still eating her Big Mac. So what I'm talking about is if we look here at the chart, about 2 minutes, 3 minutes in, you see where Alberta eventually passes Dora. You see that Betsy is slowly increasing in speed, and Alberta is catching up to Karla. Okay, she's catching up. She's gaining momentum on her. And so then Dora was still stationary, though, eating her Big Mac. So now at around 4 minutes, Alberta's steady pace permits her to pass the cheating Karla. So if we look at the graph, I'm guessing that that's about 4 minutes. Okay? So Alberta's steady pace permits her to pass the cheating Karla. Yes, Alberta has just won the race. Karla in only 30 seconds, is only 30 seconds behind and comes in second, while Dora is back on the trail. In other words, Dora had started racing again. She seems to have been slowed down by her Big Mac, and Betsy passes her by taking third place. Finally, after 11 minutes, Dora finally finishes in last place. So I have the beginning, the middle, and the end. That's how you write a good story, right? And so then Mr. Adams, what I did is I focused on the beginning. In the beginning, Alberta wasn't moving. Betsy was moving, but very slowly. Dora started off at a steady pace, and Karla started off at the 500-meter mark. After about 2 minutes, we see that Dora stopped. We see that Betsy is slowly increasing in speed. We see that Alberta is starting, and she actually, at this point here, passes Dora and is gaining momentum on Karla. So I'm describing this behavior that goes through here. Then I see that at about the 4-minute mark or shortly thereafter, Alberta passes Karla and eventually takes first. Shortly behind Alberta is Karla. She takes second. Dora starts back up, but her speed is not as fast. And Betsy is increasing in speed. In fact, Betsy passes Dora, comes in third, and Dora is in last place. And we see that this is the 10-minute mark. So I guesstimated and said that Dora came in fourth place at about 11 minutes. So this would be approximately the 10-minute mark. Okay? Any questions? So I wanted to clarify that because I think we missed that. Yeah, question?
Okay,
Shh, hold on, let me hear the question, you guys.
so like, how there, so, Betsy, for instance, like, no, Alberta. So how did you say she stopped at 3 minutes? How did she stop for 3 minutes? It seems like she just kept going.
Alberta didn't stop for 3 minutes. Dora stopped.
Okay, but you said at the beginning that she.
Oh, I see what you're saying. She didn't move at all. So if this is the 1-minute mark, how much distance has Alberta traveled? Remember that the distance is measured in this direction. How much has Alberta moved away from the x-axis?
She was moving.
No, she wasn't. She wasn't moving at all. In fact, she doesn't show any behavior. She doesn't move any distance until after about 3 minutes or 2.5.
Oh, I see what you're saying, because it's there. Oh, yeah, I see what you're saying.
So just to restate so everybody understands, the question is how can I say that Alberta didn't move for the first 3 minutes? Remember, the minutes, the time is measured this way,
Oh, yeah.
and the distance is measured this way. So at 1 minute, Alberta hasn't moved this direction at all yet. In fact, she doesn't move in a vertical direction until about 2.5, 3 minutes. Any other questions? No other questions? We understand this? Okay, good.